Okay, I think we'll get started. So the next presentation is called Bridging the Protocol Gap, and so I'd like to welcome Jeff Bohren from OpenID.
All right, thank you. Welcome to the Pragmatic Enterprise Track and the Cloud Identity Summit 2017. And my name is Jeff Bohren. I'm from OpenID, and I'm here to talk about how to bridge the older Federation protocols such as SAML2, WS-Federation, and WS-Trust, and how to bridge those with the newer protocols such as OAuth2 and OpenID Connect. To give you a background about who I am, where I'm from, I've been in building products in the identity space for about 20 years. To put that in perspective, when I started, we actually didn't use the terms identity or identity management, and certainly not the cloud. We use terms like web access management, provisioning, and everybody was really excited about the growth of LDAP. So also, when I started in the space, I had hair. So that gives you a little background on where I'm from. Okay, so now why cloud identity? Well, at OpenID, we found it really makes sense for our customers from both a reliability, scalability, and even affordability standpoint to move their identity services from on-premise to the cloud. In fact, this presentation really represents the lessons learned that we've experienced moving our customers from the on-premise to the cloud. So now that we've decided we're going to move identity services to the cloud, why do we need to mix protocols? Well, even if you've decided that OAuth2 OpenID Connect is the future of your company, you're still going to have to support legacy applications that may be SAML2, WS-Federation, or WS-Trust. So we're going to talk about those protocols, we're going to talk about tokens, then I'm going to show you some examples of transitioning between protocols. If we have time, we'll have Q&A. So some of the older protocols are obviously SAML2, WS-Federation, WS-Trust. You should all be familiar with these, possibly except WS-Trust. I like to think of that as the stealth protocol. If you are using Office 365 in a federated model, you're actually most likely using WS-Trust and you don't even realize it. So it's kind of like the stealth protocol. Obviously, these are all XML-based protocols. The newer ones, the OAuth2 and OpenID Connect, well, OpenID Connect is really an identity layer on top of OAuth2. These are obviously JWT, JSON Web Token, and REST-based. Let's talk a little bit about tokens. So a lot of people don't realize this, but WS-Federation and WS-Trust are actually built from the ground up to be token agnostic. You can actually use them to transport any token you want. However, in practice, I pretty much only ever see SAML2 or SAML2 tokens used with WS-Federation, WS-Trust. But in theory, you could use any token. SAML2, obviously, we're talking about SAML2 tokens. And then in OAuth2, we now add some more tokens. We have access codes, which are one-time use tokens. They're used to get access tokens. Access tokens are usually opaque tokens. They're used to basically allow one system to get access to users' information on another system. And that's why we call OAuth2 an authorization protocol. Then we have refresh tokens. Refresh tokens are more longer-lived tokens, sometimes given lifetimes of 30, 60, 90, or even permanent days of lifetime. Refresh tokens are typically used to allow the reliant party to get new access tokens. And then when we talk about OpenID Connect, which, like I said, is really an identity layer on top of OAuth2, we have what's called a JSON Web Token, which for some reason I've never been clear on is referred to as a JOT. I don't get it, but that's what the industry refers it to. By the way, if you say JOT token, you're being redundant. A JOT is essentially like a SAML assertion, except instead of being represented in XML, it's represented in JSON. Typically, they're much smaller for the same amount of information, and that can have some advantages from a protocol standpoint. But you can consider them, they work effectively the same as a SAML assertion. Now let's look at a typical cloud identity scenario. In this case, I'm going to have, let's see, can you see that? Yeah, you can see that. Typically, we're going to have an IDP and reliant parties on-premise. We're going to have IDPs and reliant parties in the cloud, and there's going to be a mixture of WS-Federation and SAML2. This is where a lot of people are today. Should be a model you're familiar with. Now, just for completeness, I'm going to go through the whole, what I call the federation dance, when you're going between WS-Federation and SAML2. Now, this is really, you could consider SAML2 and WS-Federation to be interchangeable from this standpoint. Yes, SAML2 is a lot more complicated, has a lot more bindings, but the way it's typically used in practice, it's very similar to WS-Federation. So the user starts at the cloud reliant party, gets redirected to the cloud identity service with the SAML2 authentication request. This is a SAML2 cloud reliant party. Now at this point, we have home realm discovery. Home realm discovery is a whole nother topic that I could do a whole another presentation on, but for now, we'll just assume that you have to figure out where to authenticate the user. The user gets redirected to the WS-Federation identity provider with the WS-Federation authentication request, authenticates on-premise, and then gets redirected back with a WS-Federation authentication response. I'm going to kind of go through this fast, but when the user gets redirected back with a WS-Federation response, now you have a potential problem. If you have the identities in the cloud, the assertion in the WS-Federation response can either be used to look up identities in the cloud, or it can actually be used to provision identities in the cloud if you're using just-in-time provisioning. But what if you have a privacy situation where you can't store identities in the cloud? Well, you can still make this work. You just have to map the assertion coming from on-premise to the assertions going outbound. If you have multiple reliant parties, and I can promise you will, the assertion coming from on-premise is essentially going to have to be the superset of all data needed for all reliant parties in the cloud or other on-premise reliant parties. Okay, so we've done the authentication. Now we're going to do the sign-out. Can't emphasize the importance of single logout. In this case, the user signs out of the reliant party. SAML2 logout request is sent to the identity service in the cloud, which turns into a WS-Federation single logout request to on-premise. In almost all practical cases, single logout is done in iframes as implementation. The reason is if you have many reliant parties and you can't really daisy chain them. It's too unreliable. It'll never work in practice. But even putting them in iframes, if the users are not patient enough to let the single logout process happen to completion, single logout won't work if the user redirects his browser to their site. Okay, so again, that was simple. That was SAML2 and WS-Federation. This should be old hat to everybody. But the takeaway is we can do this even without identities in the cloud. Single logout is supported. And we can definitely get single sign-on between heterogeneous reliant parties. That's what we're going for. Now let's bring in OAuth2 and OpenID Connect. So now we have the same scenario we had before, but now we have an IDP in the cloud that's OpenID Connect. We have reliant parties in the cloud and on-premise that might be OAuth2 or OpenID Connect. Now we're going to show you WS-Fed to OAuth2 or OpenID Connect. Now again, this could just as easily been SAML2 to OAuth2, makes no difference. The flow is going to be very similar. So the user, again, starts at the reliant party. This is an OAuth2 reliant party. We're going to use the OAuth2 access code grant, for those of you who are familiar with the different grants. So the user is going to redirect to the cloud with an access code grant request. Again, home realm discovery. The user is then going to be redirected to on-premise with a WS-Federation authentication response, as before. Do local authentication, gets redirected back with the WS-Federation response. Now that we know who the user is, now we can do the authorization step, because when we came from the cloud, we came with a scope. Again, this is optional, but if you include it in, you can now do authorization where you can allow the user to choose whether or not he wants to allow access to whatever attributes the reliant party is asking for. To assume the user okays it, he now gets redirected back to the reliant party with an access code response. The reliant party then makes a back-channel REST call back to the cloud identity service to exchange that access code for an access token, possibly a JOT as well, maybe even a refresh token. So the takeaways here is Yes, absolutely, you can extend SAML2 or WS-Federation IDPs to OAuth2 and OpenID Connect. You can even do it without identities in the cloud. We can also support end-user authorization if the relying party is an OAuth2 or OpenID Connect relying party. Obviously, we can't do it if it's a SAML2 or WS-Federation relying party because it's simply not supported in the protocols. Oh, there's important thing to note is there's no single logout in OAuth2. I know the OpenID Connect standards body is working on that, and I think they're going to have their draft out pretty soon, or the draft is out. They're hoping to standardize it soon, but it's not there yet. However, you can revoke OAuth2 tokens. All right, now everything I did so far was what we call passive authentication. In other words, it was a user in front of a browser going through the flow. The browser was doing the federation dance. Now we're going to move to active authentication. Active authentication is essentially web service calls between systems. In this case, we have a device. The device has an application that needs to get a user information from our cloud identity service. The first step is going to use the user password resource grant flow to send the user ID and the password to the cloud identity service. Assuming the cloud identity service knows where to authenticate the user, back to home realm discovery. That can be turned into a WS trust call to go to on-premise. Again, comes back with an assertion. Now we have the assertion mapping problem, which then can get turned into an OAuth2 token returned back to the device. The device can then use that to authorize REST calls to the cloud relying party. Cloud relying party can then send that access token back to the cloud identity service to get user profile information about the user and to do whatever authorization it needs to do. A good step is that the device app could actually store a refresh token instead of caching the user ID and password, which is always a bad idea. So key points, the active authentication is well suited for devices and single page applications. It's a great alternative to having an embedded browser in your application, which is what you would need if you were trying to use the access code grant, the implicit grant, or the hybrid grant. The downside, no support for MFA, no support for the authorization step because, again, since the browser is not in front of the user, there's no chance to do the authentication step. There's also no support for single logout. However, token revocation is still possible. And again, as I said earlier, the OAuth2 refresh token would be a good alternative to storing your user ID and password. All right, now let's talk about social media. So in this case, we're going to assume that your enterprise wants to expose an on-premise relying party, let's say it's a WS-Federation relying party, and we're going to allow access based on social media login. So again, the user in this case is going to start on-premise at the relying party. He's going to make a WS-Fed authentication request to the cloud. Again, could have been SAML2, but in this case, we're going to say it's WS-Federation. The cloud is going to then turn that into an access code grant request to the social media. Obviously, it has to know somehow has to know about the social media to use for this. It's going to come back with an access code grant response. Your cloud identity system will then have to make a REST call to the social media to exchange that access code for an access token and possibly a JOT. And then the last step, if not using a JOT, it might have to make proprietary API calls to get user profile information. So the key takeaways here is social media is ubiquitous. You can absolutely use social media as an IDP for enterprise logins. It's typically going to require a registration step. The reason it's going to require a registration step is the information that you get from the social media may or may not contain enough information to identify the user. So you may have to have a step where the user provides information enough to identify them, prove who they are, and allow them to decide what social media they want to use as an identity provider in the future. You also need to think about authentication strengths. Typically, the customers I work with, what they do is they assign social media login as the lowest identity strength, lowest authentication strength. Then it might be local user ID and password, certificate, multi-factor authentication. The other thing you have to keep in mind is social media user profile is typically going to require a custom API call. Most of the social media identity providers are not using OpenID Connect yet. Hopefully that's going to change in the future. It'd be great if they all go to OpenID Connect. Also, they all allow you to do some kind of logout, single logout, but it's always non-standard. Again, hopefully once the OpenID Connect single logout spec is standardized, that will change and we'll have a standard way to do it. Today, it's all non-standard. Okay, that's it. I know I went through that pretty quick. The slides, if anybody wants the slides, contact me and I'll be happy to provide them to you. So I guess we'll go ahead and take questions.
Any questions, Jeff? No questions.
No questions,
Really?
okay.
No questions? Okay, must have been perfect delivery. Okay. Well,
Either that or very bad. I'm not sure which.
all right, well, thank you very much indeed, Jeff.